Hello everyone, today I will explain several scheduling algorithms in operating systems like round robin, priority scheduling, shortest job first, and first of all is round robin algorithm. Here's a C code for implementation of this algorithm. First of all, I create structure with process that accepts 4 arguments like process ID, arrival time, burst time, and remain time, and it's a main method. Here I created array with processes. There I have 3 processes with each of them has 3 values, and n is the count of these processes, and quantum is a like power of our CPU that can execute 3-time unit process. So here's a 4 cycle, and our main implementation is a void that accepts our array and count of this process and quantum of our CPU. For example, if we run, process 2 finished at time units 14, process 3 finished at 22, process 1 finished at 23. Then let me explain this test case step by step. For example, in this first round, we have this process. For example, first process is remain time 10, 5, and 8. This is our 3 processes, and our quantum, let write this as Q, is 3. In first round, we executed 3-time units, and we have remaining time 7, and 5 minus 3 is 2, 8 minus 3 is 5. Then second round, 2 minus 3 is minus 1, so it means we already completed this process. So let's note it as completed. 5 minus 3 is 2, 7 minus 3 is 4. Then this means we have completed second process. Let's write in our stack. Then in this third round, we have 2 processes, first and third. 4 minus 3 is 1, 2 minus 3 is minus 1, so it means we completed the third process. Then in this fourth round, we have only 1 process with remaining 1 time unit. 1 minus 3 is 1 minus 2. This means we already completed this process in fourth round, so we completed first process. So it means we first completed second, then third, then first process, and our program is outputs like this. And also it summarizes our execution time, so its algorithm works well. Here is the implementation. While our processes are not done, we will execute while cycle inside them 4 with our 3 processes, and note them as 0 if it's completed and 1 if it's not. And the next algorithm is priority scheduling. Here, as round robin algorithm, I have structure with process ID, its priority, and burst time, and its method for comparing processes. First of all, it takes process priority, then compares, and returns a process with highest priority. If the process priorities is equal, it will sort with PID. For example, we have 2 processes with priority value is 1, and for example, its PID is 1 and 2, and it will return the process with least PID. Then it's a main function for priority scheduling. It uses qsort function for comparing with our method. Here we have this test case and the 3 processes, and if we run, we see that process with highest priority second it starts first, then process with PID 1 and priority 2 starts second, and the last one runs in the last order. And let me explain this. In this case, we have 3 processes with burst time 10, 5, and 8. But their priorities is 2, 1, and 3. And first of all, it runs the process with highest priority, it's a 5, and it will run until 0 time int to 5. And the second process is with priority 2, it will run from 5 to the 15, because we run 10 time units. Then the last process will run 8 time units. It will finish at 23. So I think it is clear, because here is a basic sorting. It takes a process and sorts by priorities like this, 1, 2, 3. It's a sorted priorities, then runs with 4 cycle. The next scheduling algorithm is shortest job first. As before, we create structure with but with 2 arguments, PID and burst time. Here's the compare functions. It will compare with the burst time with any words it called execution time. The shortest job first scheduling algorithm selects a process with the smallest execution time to run next. It helps to minimize execution time and average waiting time for all processes. Here, test case process with PID 1, its burst time is 10. Process with PID 2, its burst time is 5. Then if we will run this code, we will see results like this. And let me explain these test cases. We have 3 processes with burst time 10, 5, and 8. First of all, the shortest job first will select the process with minimum burst time. In our situation it's 5, and it will run the second process. Then the next smallest value is 8, and it will run the third process. Then the last one is a process with burst time is 10. It will run it in last order. So in this order, 5 and 8 and 10. Firstly, if it will run second process, then third process, and the last one is first. Here is the code output. It says process 2 starts at 0 time units and finishes at 5, because our burst time is 5. Process 3 starts next, then process 1. And let's switch to the code. Here's the main method to implement the shortest job first algorithm. Like priority scheduling, it will sort with qsort with our custom function compare, and inside just for cycle, it will increment the time and print the remaining time and starting time. It's the simplest algorithm. Thank you for watching. I hope you found this explanation helpful.